さあ皆様、今週も始まりましたよ。Cardano Radio いかがお過ごしでしょうか。今週は最後、もう第4回目のエピソードになりますね。先週はね、プラグマの、話をね、クリスティーナがいっぱいしてくれて、そしてね、今週はいろいろとまとめるディンゴの話とかね、いっぱいありますよ。今日はね、またクリスがいっぱい話してくれるので、Chris, welcome back to the show.
Hey, how's it going?
Yeah, in the last 4 episodes, I hope you learned a few words of Japanese. Okay. Never mind, yeah. So, I just mentioned at the very opening, there's a lot of projects you're, of course, involved in. And, there's the SPO perspective and, and we kind of touched off-where about Dingo and stuff. So, I think... I'm not the tech guy, so I'll give the mic to you so you can carry on from here.
Sure. So, once again, hi, Chris, the CEO of Blink Labs, and we'll talk about Dingo a bit today. So, when we came into Cardano, one of the things we had talked about earlier is how much of Cardano is written in Haskell. And my team, our platform engineers, we work mostly in the cloud, which means most of the software and things that we deal with are written in Go. So we started writing a lot of this stuff in Go. And being infrastructure people, we started at the very, very bottom. Most people start at the top and think about like, oh, how can I use this? Where we started at the very bottom and thought entirely about how it works and started by the base communication. So we figured that if we could, start with how do different parts of the blockchain talk to each other and figure out how that works, we can start from the base layer and work our way up, which is essentially what we've done. So the base layer is Ouroboros, and Ouroboros is a Go implementation of Ouroboros, which is the family of consensus and network protocols that make up Cardano. So there's different types of Ouroboros, but Ouroboros implements them. So we have Dingo, which is a Cardano node, which means its job is to communicate on the Cardano network using those protocols and communicate with other Cardano nodes. So it's used for passing blocks and transactions between different nodes. Dingo is currently designed to be a data node. And what that essentially means is you use it in your applications to pull data that you would fetch from the Cardano blockchain. So its job is to talk to other nodes on the network and collect up all of the data that is the blockchain and present them in ways that developers can use. So there's the Ouroboros protocols, which are the ones that are built into the Haskell Cardano node, which are required for communicating and being a part of Cardano. Aside from that, there's other protocols. We had spoken about UTXO RPC before. UTXO RPC is being implemented by a lot of the nodes that are being built for Cardano, and it is designed for data usage. It's designed for users to interact with, to be able to get data out of. So, one of the things that Dingo does is it talks on the network. It collects up all of these blocks and transactions that are passing along the network and indexes them. So it does similar work to Cardano DBSync, which is it takes all of these things, it indexes, meaning it looks at what the contents are, right? A transfer of ADA from wallet A to wallet B and those sort of things. And it captures all of it so that it can be easily queried. So Dingo stores all of that, stores it in its own database, and then has the ability to query that either via Ouroboros like any other node or via UTXO RPC. And so the nice thing about that is you can build a DApp directly on top of Dingo. Using UTXO RPC. It's designed so that you don't need other software other than Dingo itself. So we're building it to be low resource, and by that I mean in comparison to the Haskell node. A lot of the reasons for this are differences in design decisions. I mean, that's really what it boils down to. We also have what I would like to call second mover advantage, meaning by not being the first ones here, we get to learn from the mistakes, failures, and successes of our predecessors. So we get to learn things that the Haskell node did good and bad. So for example, they've been trying to take a lot of the data that is stored in the memory of the node and move it to disk so that it uses less memory. We get to start with that data on disk. So we start off with using less memory to begin with. So again, we get to take a little bit of advantage in what they've done. So it also means that we can provide more services with our node without it feeling heavy. So that's how we're able to have UTXO RPC on our node directly, and all of the indexing. So Dingo indexes the blockchain and makes it all available. It also acts as a blockchain node. So it passes transactions, it does peer sharing, it passes blocks, and does chain synchronization between different nodes. And so currently, the reason why we call it a data node and not like a relay or something like that is because it does not currently validate all of the data itself. So a lot of the various terminology used for nodes depends on how much trust it puts in other nodes. So Dingo requires you to have a Haskell, currently requires you to have a Haskell node that you trust to get your data from. Because otherwise, you're essentially pulling blockchain data from untrusted sources and someone can, right? So you have to have a trusted node. And that's what makes it a data node, is it requires another node to provide that trusted interface. The next step, which we're currently working on, is we're adding all of the validation to the node, which now means it'll be able to validate the data itself and determine whether or not all of it is, accurate and follows the rules of the blockchain, all of that sort of stuff, whether it works correctly with consensus. Once that happens, it can be used as a relay. Right, so now it can be used by SPOs for, essentially the front line of the blockchain. A blockchain relay node's job is to accept data, validate it, and then only share data that it personally has validated. So our goals in the near future is to make Dingo capable of being a relay node. So again, SPOs can start adopting it into their topology. And then finally, one of our, one of the last goals, at least as far as the SPO community would be concerned, is building block production. So we are looking at building block production, which means you will be able to use Dingo as a block producer. It is not necessarily a primary goal of Dingo. So the Haskell node, of course, is a block producer first, right? That's its real primary purpose. Right? And then for getting data out of it, we have other tools that use that node, like Cardano DBSync or Kupo, things like that we've talked about earlier. So Amaru is also being designed as a block producer first, right? So, its goal is to be a block producer. Our goal is more to be a piece of infrastructure. So we're building things in a lot more of a cloud native way. We're making a lot of assumptions and design choices about things potentially being in the cloud. And by that, I mean, we're taking a lot of the best practices and things that are more common in the cloud rather than bare metal hosting and integrating them. So the ability to integrate with the various security models of the clouds and things like that in how the node operates. We're building that stuff directly into the Cardano, or into our Cardano node, into Dingo. And this is a little bit different than, we had talked about, like Christina had talked about how the Japanese SPO community has their own way of bootstrapping and all of this sort of, they've had to build their own tooling around the node. And our ideas are to try to build a lot of that directly into the node. codifying that expertise essentially into the code itself. Probably our target for, like who our ideal user would be, as far as Dingo, would be more, I'm going to say, like the casual business user. And what I mean by that is businesses that are going to start adopting blockchain and blockchain use, but it's not necessarily a primary part of their business, right? It just ends up being a part of their business. And you think about this and you think about stuff like that, and, we hear about real world assets, right? So it's like, oh, well, we've got the farmer, right, who's building all of this stuff, and he wants to track his inventory as, it leaves his farm and gets sold out and things like that, so we're using a lot of this for tracking. Those kind of businesses would be more like what I would see using Dingo, in that it is designed more for a user. In the way that it's built, it's designed more for a data application. It's designed more for data first, as in most of the time you are consuming data from the chain, not writing to it. Right? Like the assumptions and the designs of a block producer is that you're probably going to be writing to the chain. Right? Like the reason why I'm sitting here is I'm waiting to write to the chain. I am a part of the chain and I'm writing to it. Whereas a lot of times your average application from your average business, you think about on the internet, right? Like most of the time it's consuming stuff, right? Very, very rarely is it producing, right? And so there's different design trade-offs and things like that you do in this sort of a system, right? For making it easier to do things, you might make simplified interfaces, so it's an awful lot of steps, for example, to create an NFT using Haskell node and the interfaces that are available for that. In fact, it's difficult enough that most people write entire separate pieces of software that run on top of it just to do that task, right? Because that's not its primary purpose. Whereas for us, we could have very, very simple, like Mint NFT interface. And that would be appropriate for us to put into our software because of our target user. Right. So with that being in mind, block production will be a use of the Dingo node, but because it's not the primary, like we would not necessarily be targeting SPOs that are just SPOs. And I don't mean that in any kind of negative way. I just mean, where they are an SPO and their primary job is to be an SPO. Yeah. The people that would most likely use Dingo would be someone they're an application developer and they're building an app and they also want to run a stake pool. So to them, running the stake pool is secondary, right, to their primary goal of running the application. And now running a stake pool is like, oh, okay, well, turn on that feature on Dingo. Right. So that's kind of the idea. So we're not looking to like replace the Haskell node for your average SPO, but we are looking to replace it for your average data application consumer and builder.
I see. Yeah, well, when you're talking about the Dingo's, the BP right now, the block producer node, my buddy's he's heavily into the coffee industry, and he goes to Guatemala and everywhere, and he does the specialty coffees and exactly what you're talking about. He wants to put the info on the chain. So I think I should mention about that to him. I mean, that was a perfect example you gave me about farmers and stuff too. So.
Right. Yeah. And that's the idea is we're building it with different assumptions, so to speak, right, on how it works, different security assumptions, so that it is more geared towards, like I said, the end user. And the important part is really the interfaces, making it so it's easier to interface with. So one of the other things that has become common, and this I kind of didn't talk about before, is block frost, right? So block frost is a data service. So it's an API service that many apps in our ecosystem use. In fact, it's so popular that they have started to try to transition from being a, let's say, a service into a program. Meaning they're trying to get other people to implement the features of their service. And so BlockFrost has talked with us and with TX Pipe. And so one of that we're trying to build is what we're calling mini BlockFrost, which is the core of BlockFrost, and adding it to our own nodes. So if you use TX Pipe's Dolos, it currently has mini BlockFrost that you can turn on. And so the idea is again, all of these heavy layers get shrunk down into smaller pieces that are usable by an average person with a standard use case. Where again, they're looking at blockchain not as a primary goal, but as a secondary goal. Right? Like you said, the farmer is a farmer, right? Like they're not a blockchain person, but they can see the use of a blockchain for provenance, for tracking inventory, things like that. So they're looking at the chain only for its benefits and only for its uses, not for its tech, right? They don't care about the tech of the chain. They just, right? Like they're like, I just want to track my stuff. So they care about the guarantees of the chain, what the chain provides them, but not like they don't care about the technology at all. And so that's kind of the thing is sometimes, especially guys like me, we get a little too invested in our tech and forget that a lot of times people just want to get things done.
True.
And so our idea with Dingo is to get stuff done. And so we're trying to target lots of environments, from small to large. One of my targets is to try to be able to run Dingo on a phone.
I see. Well, that was very, very simple way for you to put it, and it was very easy for me to understand. Thank you very much.
Oh, no problem.
And one, it's getting to a wrap soon. But one question, not question, but I wanted to ask you about this. Is that like probably maybe 10, 15 years ago when you're still probably heavily into the programming and everything, but now we have the AI taking over a lot of part, ChatGPT, whatever, Claude, Augment, and you name it. There's a lot of things coming into this area, and for program, when I get stuck, when I get lost, I ask the AI and it helps me out. It's simple because I'm not like a super pro programmer. And when I use my brain as a musician, and they got Suno and they got all different kind of AI software that you just say, I feel happy, I want her to smile, make a song, boom, the song is ready. You know what I mean? And that's kind of good and bad in so many ways. But being a musician's brain, it's okay as a starting point to like use that as like a branch to build on top of it. And because I'm a musician, so I can build on top of it, maybe export it once and re-import it back into the AI and export it again and just boom, make your own thing. I understand that part as a musician, but as a programmer and being a developer making software and stuff, if you like put what I said into your words, do you think it's a good thing that AI is getting very clever for people as a starting point, or is it not that good for the ChatGPT and everything to be too smart?
I mean, well, obviously it's good for AI to understand. I mean, the more that it understands, the better. But where the line is drawn is how you use it. Like as you said, using it as a starting point or as a building block or using it as a piece of the things that you're doing is great. It's when people are having AI do everything, right? And it's the same thing. It's the same thing in music. It's the same thing in software, right? If you just completely produce it entirely with AI, you end up with what everyone calls AI slop, right? And it's because what it is it's the easiest way to explain it is what AI's job is. It's like a prediction engine, right? And so what I mean by that is like if you just only made music from using AI from now on, right? Over time, everything is going to sound like the exact same pop. Because that's what's most popular, right? Like, so what's going to happen is over time, it's going to converge into that singular, right? Like everything sounds the same. It's all, right? Because it's all formulaic. The software, it's basically the same thing. right? So you don't end up with great software. You end up with average software. And this is what happens over time is it becomes more average because it's trained on itself, right? Like it's its own feedback loop. And so just like with music, you know, you end up with very, very similar, but not brave or, you know, challenging kind of code, right? Like you don't have anybody that's breaking out of the box, nothing that's doing anything new and unique. So AI helps with learning and it helps with understanding, but it does not help with creativity.
True. Yeah.
And I think that was kind of what you were getting at, right? Like, you know, you can say, oh, AI, go make me a music. And then you're like, okay, cool. That's boring. Yeah. What it creates, right? It's formulaic. Yes, exactly. It's like, it has no soul, right? Like it has no human feeling behind it. So code is very similar in a lot of ways. When you're writing code and you're using AI, you can almost feel a pushback sometimes where like the logic of the AI isn't making as much sense. And it's a very similar thing where it's like there's a lot of feel involved, which is where, you know, some people feel like their code is art. And it's because it is very subjective in a lot of ways in how things are written and that sort of stuff. So, you know, you can make code beautiful or ugly, right? You know, and those sort of things. So I think it's a very useful tool. I've been learning to use it because it is, you know, like the way that a lot of the software industry is going to go. I don't believe we will move to a place where AI is doing the writing for us, you know, for the reasons we said. We really have to keep the humans involved in that process. But it does allow us to accelerate. And hopefully it allows us to lower the barriers of entry. And I think that's a lot of it, right? Is being able to make it so that an average, you know, non-expert person can come into something and have a level of proficiency or a desired level of proficiency fairly quickly. You know, you're never going to be an expert using AI, right? But you can be a beginner. You can learn. Right, like you can go beyond that initial frustration sometimes by using AI.
Thank you. Yeah, that's one thing that I was thinking about while we were talking in the last 4 episodes, and you know, I just wanted to put it in somewhere, and you answered it perfectly. Yeah, well, that was that. Oh, that's another wrap. But it was quick. 4 episodes went flying so quickly. I mean, you know, I know you're really busy, and thanks, you know, so much for your time. And please say thank you to Christina as well for, you know, joining in. It was you know, great opportunity to have you on the show, and hopefully, you know, in the near future, if I can have you guys back, and you know, maybe in Japan, if I can see you guys, that'd be great too.
Yeah, absolutely.
Oh, I forgot the most important part. Like how Santi introduced me to you was, you know, introducing me to another guest. Remember? And
yes.
I was hoping if you can introduce me to, you know, if you can't really pick somebody up right now, maybe even with Discord a little bit later is fine. If you can introduce me to the next guest of the show, that would be very grateful.
Yeah, we'll have to talk and find out who you've already talked to.
All right, that's for sure.
I was like, well, Pi and Santi, you said you've already talked to. So.
Yeah.
This is my favorite part. Tell us who you want. I know everybody.
You want to get Adam on the show?
Yeah, have you had Adam on the show?
Well, Adam actually, I was supposed to have him in November, but he was in Berlin and stuff. But yeah, I'll have him. Don't worry. I'll make sure he'll be on the show. He wants to be on, but yeah, I would.
Yeah, we'll sync up on Discord and we'll figure.
All right. Well, again, Chris and Chris, thank you very much. I had a great time, and we'll keep in touch. Thank you very much for joining.
Thanks, Chris. Bye.
Bye.
Stability indigo's right. USDA come and trust decentralized. Decks are trading, pools stay deep. Stake, delegate, rewards to keep. Midnight with us, protecting the right. Privacy balance with laws in sight. Identity verified, freedom intact. Zero knowledge whispers guard every act. From Voltaire's voice to Treasury song. On-chain decisions.